We've all heard of the scientific method since we were little, and one of the key parts of the scientific method is the hypothesis. Today, you and I are going to enter the world of hypothesis testing.
Let's first define hypothesis as simply as possible, an idea that can be tested.
Follow me outside and let's see what we can make a hypothesis on.
I've had this bird feeder here for a while, but it doesn't seem to be attracting very many birds. I wonder why.
My hypothesis is that the nuts in the feeder aren't very enticing. I'll switch out the nuts for something different, like sunflower seeds, to see if more birds show up.
I know that from previous experience with my old nut-filled bird feeder, an average of 3 birds showed up per hour. But now by replacing nuts with seeds, I'm hoping that this average of 3 will increase.
Let's put this into proper notation. Our null hypothesis is that the mean, mu, is equal to 3. This is assumed true unless proven otherwise. Our alternative hypothesis is that the new mean after using seeds will be greater than 3. This is at least what we're hoping for. Now, let's run the experiment. I've set my iPad here to time-lapse to record the number of birds that show up to my new seed-filled bird feeder for the next few days. Let's put our data for seeds in a table and calculate the average. It's 3.5. Well, we have our answer. Since an average of 3.5 is higher than 3, seeds attract more birds. Not so fast though. In order to do this properly, we first need to calculate the p-value, which is the probability of having a type 1 error. In our experiment, a type 1 error is if we somehow falsely got a result that seeds are more effective than nuts, while actually nuts are more effective than seeds. Our p-value, using some fancy calculations, ends up being 0.11. Most scientists use the number 0.05 as a benchmark. Since our p-value of 0.11 is greater than 0.05, we fail to reject our null hypothesis. In other words, we actually cannot conclude that seeds are more attractive to birds than nuts. As scientists would say, our result is statistically non-significant. I know what you're thinking. How could this possibly be? Our average for seeds was obviously higher than for nuts.
Here's the catch. We need to give room for sampling error and variability. That's why hypothesis testing exists. It is likely that if we take another 10, 20, or 100 samples, we could get a different result and that nuts actually attract more birds than seeds. But we just got lucky with this one sample of seeds because of factors we didn't account for. The possibility for error is endless, and we always have to account for it. And because every science experiment, no matter how rigorously planned or detailed it is, will always have error, scientists of all fields use hypothesis testing methods such as null and alternative hypotheses, type 1 errors, and p-values, just as you and I have learned today.